Hi everyone. Today's lecture is about the LNG, which is the liquefied natural gas. So actually it is a methane gas, same gas that we are talking about, but it is in the liquefied form. So what we do, we play with its critical properties. We reduce its temperature to minus 161 degrees centigrade in cryogenic temperatures, and we convert it into the liquid, and then we transport, and then we gasify it. That's the procedure of it. Remember, it is the LNG is different than the NGL, because NGL are the natural gas liquids. These are the heavy hydrocarbons. Those are obtained during the processing of the natural gas. When we purify the natural gas, there are some liquids come out of a solution and form the separate phase. We call them the natural gas liquids, or you can say condensates at the same time. But LNG is a methane gas, but it is in a liquid uh, form. So, what is liquefaction process? Well, first of all, the converting the natural gas into the liquid is called the liquefaction process. So we just liquefy it. How we do it? We compress it. We compress the gas at temperature less than its critical temperature. So we compress the gas at minus 161, and it becomes the liquid. So that's the main process, and two processes usually are used. One is the cascade process, and other one is the JT effect, joule Thomson effect. Compress and then rapidly expand the gas. Usually this one, JT effect, is mostly used in this process, and that we will discuss in much details in the coming lectures. And what temperatures we keep? Well, we keep here, as you can see here, methane minus 161. At this temperature, what we do, we put keep this gas at this temperature, and the gas becomes the liquid, and then it is easy to transport in a tankers. But again, we have to maintain the temperature at the liquid. There's also, so cooled until it liquefied at minus 160 degrees centigrade. And remember, there is one important thing here, that the volume is reduced to 600 times. That's the 600 times its volume is reduced. So it is easy to transport. For example, if you want to transport without the compression, it is very hard because the volume is just too much and it takes the shape. What we do, we compress it. When it becomes liquid, it's very much compressed, 600 times compressed. So when it is compressed, you can easily transport using any tankers, but we have to maintain the temperature of minus 160 degrees. And it is colorless, odorless, and it is quite safe. And I will show you in a video, like when we put it even in the air, it is not catching the fire so easily, and shipped and stored at the atmospheric pressures. So we just maintain at the normal temperature pressures and keep these minus 161, and we can transport it to the any part of the world using those special tankers that I will show you. So now let's look at the LNG chain, what it does. Like now we know that, okay, we have the natural gas methane, we make it as a liquid, and which is easy to transport. So what we do? Well, first of all, as you can see here, the we get the gas from these gas wells. Once we have the gas from these gas wells, we process them. What is the meaning of process? It means that we remove the impurities like CO2, natural H2S, and nitrogen, and so on. Then we send this, okay, to the liquefaction plant. So here in liquefaction plant, we just play with the critical properties. We maintain the temperature minus 161 degrees centigrade, and we make it a liquid. Once it is liquid, we ship it to the customer. For example, now you have a gas in Kurdistan. You can purify it, make it a liquid, and put it in the tankers and send it to anywhere in the world. So using the sea route, we can ship this LNG to any country. Let's say you are selling this gas to Germany. So you sold this gas to Germany, liquefied gas. They ship it there. There they have the gasification plant. They will again make it a gas, and then they will send it to the market. So that's the main idea of the LNG chain. They started from the gas well. So it has the liquefaction section, it has the gasification section, it has the shipping, and so that's all the business of the natural gas. And it could be, as I said, could be the game changer for Kurdistan if they change this, convert this natural gas into liquid and sell it ahead, and so on. So natural gas liquefaction, what is the plant? How does it do? As I say, we have to compress it, compress compress it. So what we do here, we are using the refrigerant loop, very cool, and we have the big tower, and we maintain the temperature minus 161. We compress this gas, so gas is coming from the purification plant. We remove all impurities. The gas is coming there. We increase its temperature, and it goes through. We compress this one, and at the same time, this becomes the liquefied gas inside this tower, and then this LNG storage goes there. So these compressors are for these refrigerator loops, and they compress it here also inside. Here at the same time they maintain the temperature minus 161 degrees centigrade. By doing this, they will uh, it will become a liquid form, and then this LNG comes inside the storage. These storage are also very special kind of storage. We call them cryogenic storages because we have to maintain the uh, the the temperature inside, which is minus 160, and and also we have to make sure that the inside outside heat should not affect the inside. It has to be quite thermally insulated storage. And then once you have stored, you can put it in the ship and so on. So now I will show you that how this chain overall works in a video, so you learn the process.
Heat and cold. Shakespeare told us to fear no more the heat of the sun, nor the furious winter's rages, and natural gas now rises above other fuels to beat those forces back. Natural gas is abundant, at least in some parts of the world, but how do we get it from regions that have it to regions that don't? So we cool natural gas until it condenses into a compact liquid. Now we can ship it on special tankers. Natural gas is mostly methane with varying amounts of other hydrocarbons and impurities that can freeze and foul equipment. We remove the impurities in the pre-treatment area of the LNG plant. Here we also remove heavy hydrocarbons, inert gases, and other gases that accompany the methane, that is, natural gas. Now we can begin to liquefy this clean gas. Many technologies can do that, but all are based on the same cyclic process that serves our kitchen refrigerators. That means we need some kind of refrigerant to remove heat from the gas so it'll condense into liquid. Here's how it works. First, the liquid refrigerant expands from a high pressure to a low pressure, turning it into a cold mixture of liquid and some vapor. Next, it passes through a heat exchanger that uses heat from the natural gas to turn the refrigerant into pure vapor. The natural gas is now a lot colder, and we can compress the refrigerant back to its high pressure. We cool the hot refrigerant in another heat exchanger until it condenses back into liquid. Then we expand the refrigerant again to repeat the cycle. The key to cooling and condensing natural gas into LNG is flashing the liquid refrigerant. And once the gas is LNG, we store it in tanks at very nearly atmospheric pressure. Liquid natural gas looks like water except that it boils off at room temperature. It's odorless, colorless, non-toxic, and virtually non-flammable. The cryogenic LNG stays in these storage tanks at a constant temperature between minus 159 and 162 Celsius. Evaporation helps keep it cool and liquid while it's stored on land or in the ship. We capture the vapors and either burn them for fuel or we recondense them and send them back to storage. Who then uses the LNG? Typically a power plant or industrial user. They convert the liquid back to a gas so it can be burned as a fuel or used as a feedstock. More than half of today's LNG comes from just 4 countries: Qatar, Indonesia, Australia, and Malaysia. But that's soon likely to shift. New natural gas discoveries promise to send Australia, the U.S., and Africa to the forefront. The companies that build these plants have much to think about. Who'll buy their gas? How best to meet buyer specifications? How much LNG will buyers want? Another thing, buyers have to make long-term commitments before suppliers can invest in new units. If this is a golden age for natural gas, it rests upon vast ingenuity and daring. What gulfs of heat and cold we must cross to provide that elixir of warmth anywhere in the world.
than a blaze. This is different from other gas fuels such as propane and gasoline, which are highly flammable. As LNG mixes with more air, the mixture becomes too lean to burn. This is called a lower flammable limit. Now it's important to understand that natural gas does burn. That's why it's an efficient and versatile fuel. However, for LNG to burn, it must be in a gaseous state in combination with air or oxygen. Within its storage tanks, LNG is always maintained in a liquid form, with natural gas vapor but no air above the liquid. The tanks are also well insulated and vapor tight. This means not only can oxygen not seep in, but LNG cannot seep out.
Natural gas will be the world's fastest growing major energy source through the year 2040. This energy source carries tremendous benefits for consumers and the environment. It is versatile, clean burning, and abundant. Natural gas resources can be located in remote areas, and these resources are produced from subsurface reservoirs, both onshore and offshore. A complex value chain transports natural gas to consumers around the world. The value chain begins with the process of bringing natural gas to market by safely drilling wells to bring the gas and other reservoir components to the surface, where it may be processed on-site or transported to a facility for treating and processing. Natural gas extracted from subsurface reservoirs can contain non-hydrocarbons, including hydrogen sulfide, nitrogen, carbon dioxide, and water. The treatment processes remove these components from the natural gas. A solvent is used to absorb carbon dioxide, hydrogen sulfide, and water. Heavier liquids are removed from the lighter gas for separate processing. Water is removed, and the remaining natural gas is ready to be cooled into a liquid. Depending on the source of the natural gas, it may need to be transported to a liquefaction facility. The gas is transported by pipeline and can travel hundreds of miles or just a few feet to a liquefaction facility. This depends on where the gas treatment facilities are located relative to the liquefaction plant. The liquefaction plant cools the gas to negative 260 degrees Fahrenheit, or negative 162 degrees Celsius. As the gas cools, it is reduced to 1/600th of its previous volume. The resulting liquefied natural gas is clear, colorless, and ready for transport. The liquefied natural gas, or LNG, is stored in large insulated tanks until it is ready for shipment. Pipes connect the storage tank to a loading jetty. Regardless of outside temperatures, the LNG inside the tanks and loading facility remains at negative 260 degrees Fahrenheit or negative 162 degrees Celsius. The LNG is then pumped into specially designed LNG ships. LNG shipping tankers transfer natural gas around the world. Some of the largest LNG ships, such as the Q-Max, are longer than 60 city buses. And each Q-Max LNG ship carries enough natural gas to power 70,000 homes for 1 year. When the LNG ship arrives, it is guided to the receiving terminal, where the LNG is unloaded and stored in insulated tanks. The LNG is then pumped into a regasification plant, where it is warmed and converted back to a gaseous state. The natural gas is then ready to complete its journey. A network of pipelines delivers the natural gas to power plants where it is used to generate electricity for urban areas, to industrial facilities for the manufacturing of steel, automobiles, and chemicals, and also to homes and office buildings for heating, cooking, and drying clothes. ExxonMobil is committed to successful.
So that was the introduction of the liquefied natural gas, and let's continue further. Yes. So this was the plant. of the liquefied natural gas. Now, as an environmental friendly, it has no ash, it has no hazardous material. As you saw in the video, the vapors were not as flammable as propane or others, so you can easily transport. Even when we put this LNG in the ship, in the pot of the fish, didn't had any big effect. So it's clean, easy to transport, and cheaper than other hydrocarbons, and is a good source for the power stations, and for heating, cooling, heating systems, and so on. So that was the introduction of the liquefied natural gas, and now we will talk about the types of plants that we have for LNG. Now we will talk about the types of plants that we have for liquefied natural gas. Basically, we have two kinds of a plant. The number one is the peak shaving plant. We call it peak shaving plant. Peak shaving plant. In this kind of plant, we have actually above ground storages. We have liquefaction. We have storage. We have regasification plant. So peak shaving plant, it has all the options. Then we have another type of plant. We call it a satellite facilities or base load plant. In this one, we have only storage and regasification unit. So these satellite facilities are available at the buyer's place, where the customer buys the liquefied gas and then he has to regasify. So in this case, the both are needed uh, around the world. So this is the peak shaving plant. As I said, it has all the options. It treats the gas, it compresses and liquefy it, then it is stored, then it is regasified, ordered and sent to the gas pipeline, sent to the other parts of the country. So it is a complete cycle. Here, there, here we have a complete cycle. We have liquefaction, we have regasification, we have storages, we add some mercaptan and we send into the pipeline. That's what the peak shaving plant is. Then, uh, and this is the base load plant. The base load plant actually, as I said, is mainly depends on this part, because it has the storage and regasification. These are usually located in the buyer's place, where the buyer bought the gas and he has to regasify it and sell it and so on. Now look at this. These are base load plant where we have Algeria, Libya, Nigeria, Australia, Brunei, Indonesia, Malaysia, Oman, Qatar, UAE. They have all base load plant and they are using LNG. So it's quite popular. So it could be viable for Iraq also to follow the same as around the world. Well, as you see, the major cost is here is around this transportation. Okay, transportation for Qatar is quite expensive, and you can see that liquefaction also has a cost, regasification also has a cost. So Indonesia one is quite cheaper than the Qatar and North. These are the old figure 2001. Of course, the prices changes every day. So the prices are these are the 2001 prices. So you can make the prices based on today's current scenarios. As I said, we have to have a minus 161 degree centigrade to have the LNG. And so, as I said now before that, now as I said that the gasification to liquefaction is done using the JT cycles. So Joule-Thomson process can be used to convert the natural gas from the gas to the liquids. And let me show you the diagram how it affects. Here is the JT diagram. That's how it looks like. Here's the JT diagram that we have. So here, so it has 6 steps. First of all, the gas is coming out. It is heat exchange. Then there is another heat exchanger. Then there is the jetty valve. Then we get the liquid, and then there is the loop, because there are some gas vapors it goes back. So we will discuss one by one what are those options that we have here. First of all, we have to understand what is a Joule-Thomson cycle. What is Joule-Thomson effect? Well, what it is? It is the change in temperature when the gas is expanded. Okay, adiabatically from one constant pressure to another in such a way that no external work is done, no net conversion of internal energy to kinetic. So what it does, it just expands the gas and cools it. So we keep the pressure constant. Okay, and we expand this gas under constant pressure, and when the gas is expanded, it cools down and it can form the liquid also at the same time. Okay. Joule-Thomson coefficient may be positive. Gas cools upon expansion. That's what the process is. Now let's look at the process of this one. Well, we have 6 steps here. Number 1, uh, we have number 3, 4, 5, 6. So let's look at it. What's going on? The number 1, the liquefaction cycle begins with the natural gas being compressed and sent through the heat exchanger. So the when the gas is coming from this wells, it is compressed because it needs a pressure. So we compress this gas, and then it is air cooled, because when we compress it, it gets the heat and it becomes very hot. So what we do, we air cool heat exchange. There are air heat exchangers, and then the gas become cooler. So when this gas comes inside here, then we have the another step here. Then we talk about it. Okay, here in this heat exchanger, the it the gas is expanded from 1500 psi to 14.7 psi, and the temperature is around 47 degrees centigrade or 84 degrees Fahrenheit. And again, as I said, the gas is mainly the methane gas. So we expanded the gas under from 1500 psi to 14.7 psi. That's the main expansion we did here. But it's not, the liquefaction does not happen here still it is just cool, because as I said, the temperature is needed minus 161 degrees. So what we do, it has to go through this jetty valve, and this jetty valve is actually helpful to, so low pressure gas is recycled through the heat exchanger for recompression, and then it goes through the heat, here it goes through the heat exchanger jetty valve. Once it crosses through the jetty valve, the gas now reaches to the temperature of minus 161 degrees centigrade, and then it liquefies here. You can see it has some gas and some liquid, but not all the gas is liquefied. There are some still gas papers available here. So what we do, these gas particles, we send them back to the heat exchanger. We try to expand them again, then they process again JT wall. So whatever liquids become, we take out the liquid from here as an LNG product, and otherwise the gas goes back heat exchange, cool down again, expand it again, and in the end we get the liquid. And then, so this is the simple JT valve process. But usually the JT valve is used, as well as the refrigerants are used in order to liquefy this natural gas. This is the another process from the natural gas guideline. We have JT valve here already, and we have minus 161. Here is the heat exchangers we have, and we have compressors here, and then we get the LNG storage. And here you can see the temperature, the pressure is 300 psig, and here the pressure is 10 psig. So from here to here, we use the JT valve, and we reduce the temperature to 300 to 10 psig, and from minus 1 degree Fahrenheit to minus 2 degree Fahrenheit, then we store it. So that's another process, which is the natural gas pipeline above 300 psig, 14 degree Fahrenheit. We dry this gas, we send through the compressor. There are heat exchangers that cools it down, and then it crosses through the JT valve. Once it crosses through the JT valve, it becomes a liquid, partially become liquid. Then we use another JT valve, it becomes complete liquid, 10 psig, minus 260 degree Fahrenheit, and LNG storage. So that's the introduction of the liquefied natural gas. What is it, and what kind of plants we are using. And I showed you some videos about the liquefied natural gas. I hope you like the lecture, and we will continue further about this.